Hey students, welcome to my AP Statistics class. Today we're going to learn Chapter 12, Inference for Distributions and Relationships. Our goal today is to make inferences about relationships between two or more categories of a categorical variable. Let's start off with section 12.1, Chi-square test for goodness of fit. To start off, we're going to use a bag of M&Ms as an example to calculate expected counts of a chi-square test. With the bag of M&Ms, we're going to be able to state our two types of hypotheses. The null hypothesis assumes that there is no significant difference between the observed and the expected value. The alternative hypothesis assumes that there is a significant difference between the observed and the expected value. Using the example of the bag of M&Ms, you can make the null hypothesis that the distribution of color in the bag of M&Ms is the same as the expected value. On the other hand, you can make the alternative hypothesis that the distribution of color in the bag of M&Ms is not the same as the claimed distribution. The expected count is the one already stated by the null hypothesis. With the bag of M&Ms, we'll be able to find our observed value. We can start off by sectioning off all the different colored M&Ms in the sample of the bag. Then you can count the number of each different color M&M. Once you've counted all the different color M&Ms, you can make a one-way table for the observed value. Now that you have your observed and expected values, you can perform a chi-square test statistic. As you can see, the chi-square test statistic for the sample of the 100 M&Ms is 13.4. In addition to the chi-square test statistic, there is also a chi-square distribution. The chi-square distribution is defined by a density curve that takes only non-negative values and is skewed to the right. In the chi-square distribution, as the degrees of freedom increase, the density curves become less skewed, and the larger values become more probable. The last thing you need to know about 12.1 is how to carry out a test. When performing a chi-square test for goodness of fit, there are certain conditions that are required. Those conditions include that the data come from a random sample from the population of interest. When sampling without replacement, the sample n is less than 0.10 of the entire population n, and all expected counts are at least 5. Now that we're done with 12.1, we can go into 12.2, inference for two-way tables. Similar to the previous section, we will be starting section 12.2 with stating hypotheses. This time, we'll be stating hypotheses for tests for homogeneity. But instead of forming hypotheses for a one-way table, we will be forming hypotheses for chi-square test based on data in a two-way table. For this lesson, we can use the example of types of background music. So, we can create the null hypothesis with the example that there is no difference in the true distributions of entrees ordered at this restaurant with no music, French accordion music, or Italian string music is played. For the alternative hypothesis, there is a difference in the distribution. So we can use the example that there is a difference in the true distributions of entrees ordered at this restaurant with no music, French accordion music, or Italian music is played. The two-way table can be found the same way as the one-way table in 12.1. Once a two-way table is created, you can then calculate expected counts for a chi-square test based on data in a two-way table. Using the two-way table formed from the example, we can then calculate the expected count of the x-squared test statistic. Also, like 12.1, the conditions for performing a chi-square test for homogeneity are random, 10%, and large counts. The data must come from independent random samples or from groups in a randomized experiment. When sampling without replacement, n is less than 0.10 of the entire population n for each example, and all expected counts are at least 5.